let me take care of myself. Oh, it's gonna be like a weird angle. Does it feel weird having the robot next to you? Yeah?
Especially when you walk over there, you have to like move.
Okay. Well, I just make it stuck, so it doesn't move. So it's like just showing the screen.
Before you've done that.
I have done that before. Like if I walk in the back, it like gets you. Yeah, I remember that. That was a good day. That was a good day. Okay, so today is the finale of chemistry. You're going to split your paper in half all the way down. All the way down. All the way down. And on the left, we're going to talk about the reaction. So we're going to talk about what is a chemical reaction. So we're going to start on that side. So we're going to go with the basics. So a chemical reaction, I'm just going to give you a couple basic things, is used to show what happens. It's used to show what happens when elements and compounds react together. So we've been making compounds. We know how to name a compound, which is super important for this. But now we're going to start reacting compounds with each other. So we're going to make new compounds. Did you guys know that cheeseburgers are 50 cents at McDonald's today?
Why?
I don't know, but they are. That's what I'm having for lunch today. 50-cent cheeseburgers.
All day? Can you get me one?
All day. Well, not till lunch starts, but yeah. All day. It's breakfast right now.
Oh, yeah.
50-cent cheeseburgers. That's my lunch plan. So, because this is a reaction, we're talking about chemical equations, these use math. And the good thing is, you are an honor student. Math, yeah. These use math. And because you're an honor student, you're good at what?
Not math.
Math. All right, you're good at math.
That's what I didn't do last night.
Your math homework, right? Am I right? Every math equation has a what?
Answer.
Equal sign. All right? But we don't have an equal sign in chemistry, okay? So we are going to use an arrow for equals. But we don't call it equals. It is called, anybody know what we say in a chemical equation? We don't say equals. It's called yields. So the arrow is called the yield sign. So we'll say something plus something yields something plus something. So we don't say equals, we say yields.
Why did you say equals?
Because we don't. I don't know why. That's just what we say. It sounds more fancy that way. Sounds fancier that way. This next part is what we've been doing. I'm going to write it down. We're going to use subscripts. Science is so extra. We're going to use subscripts to balance. What's a subscript? The little numbers, right? Yeah. Yes? We're going to use subscripts to balance out individual compounds. Individual compounds. Would you agree that's what we've been doing the last 2 weeks?
Yes.
That's our crisscross, right? We've been bringing the charges down and they've been turning into subscripts. Yes? Are you guys okay with that? Okay. The new thing is we're going to use coefficients. And what is a coefficient?
Is that the thing in front of the variable?
That's the big number in the front, right? The big number in the front to balance the whole equation. To balance the whole equation. So we're going to use coefficients to balance the whole equation. Why would you have to balance an equation? True. Equations must be balanced because why? If I start out with 8 atoms on one side, I have to end up with 8 atoms on the other side. Why? Due to what? Whoa. That got crazy. Why must they balance an equation? There's a law we have to follow.
Is that due to?
Due to the
Due looks like a D. That looks like due.
D-U-E-T-O. That's a T.
Due.
Have you guys ever heard of the law of conservation of matter?
Oh.
Ah, the law of conservation of matter. And I'm not going to write it out, but what does the law of conservation of matter say?
Matter can't be destroyed or created.
Matter cannot be created or destroyed. It can only change forms. That's why we have to balance equations, because it can only change forms. We good so far? A couple more basics. Everything to the left of the yield sign, everything to the left of the yield sign is called the reactants. So my ingredients, or what I'm starting out with, are called the reactants. And everything to the right of the arrow, anyone know what those are called? It's called the, so I'm baking a cake, right? What are my reactants when I'm baking a cake? Flour, sugar, eggs, butter. What? Yost?
Why does the left arrow go to the right and so is the right?
No, I'm saying everything to the left of the arrow.
The oven.
Of the yield sign. This is the yield sign.
Okay.
The equal sign. So everything to the left of the equal sign is what I'm saying.
But what about the right?
Everything to the right of this sign. So I'm saying everything on this side of the arrow
Reactive.
and everything on this side of the arrow. That's what I'm saying there.
The reactives.
Okay? The reactants is what I'm starting with, my ingredients. But everything to the right of the arrow, what I end up with my cake, is my products. So what I end up with on the other side of the arrow is my products. So let's give an example. So if I had Mg plus P, here's your first chemical reaction. All right? First chemical reaction. First of all, could you write a product?
Maybe.
Yeah, you could. What?
MGP.
Nope. What's the charge on magnesium?
2
Plus 2. What's the charge on phosphorus?
3 minus.
Is that a perfect match? So what do I have to do? So it's actually, so you can see you cannot do this chapter without last chapter. Okay?
How did you get MGP arrow MG3P2?
Well, this is my I gave you the reactants, right? Yes? The arrow is what I'm ending up with. Over here, I know that magnesium is a 2 plus, phosphorus is a 3 minus, and I crisscrossed. Just like what we've been doing. Agreed? So I have the charges, got to crisscross. Okay, the next thing I would ask you, is this equation balanced? Do I have the same amount of everything on both sides?
No.
No, I don't. I have 3 magnesium on this side, but how many magnesium on this side?
1.
Uno. So, it says we're going to use what to balance the whole equation? We're going to use coefficients. So what coefficient do I have to put in front of magnesium?
3.
3. Excellent. Now is it balanced?
No.
Still not. My magnesium is good because I have 3 magnesium, 3 magnesium. What coefficient do I have to put in front of phosphorus?
2.
Bada boom, that is balanced. You have just written and balanced your first equation. All right, you've just written and balanced your first equation. So if I said, what is Mg3P2? How would you label that? That is a
Product.
product.
So then we go to the reactants.
That's a product. And if I said 2P, how would you label that? That is a reactant. That's a reactant. If I said the big 3, how would you label that? That is a coefficient. Good. So you're good with those parts.
Couldn't we work backwards from the product then to the reactive?
Could we? When you get to AP Chem, yes. All right? You could work backwards, but we only work forwards in freshman level chemistry. All right? We only have to work an equation one
What's the
way.
difference between CP and AP Chem?
CP Chem is the prerequisite for AP Chem. So CP Chemistry is a high school level chemistry. AP Chemistry, you're taking it for college credit. So I'm basically teaching you your whole first semester of chemistry for college.
So isn't that like where AP Chem is if you have like a B plus, it equals out like an A plus?
It's weighted.
Like,
Yeah.
It's a 5.9.
It's weighted. Okay. Yes. So that's the basics. We are ready to learn the 5 types now. Ready to learn the 5 types. Today I had a healthy breakfast. I had a granola bar. Because I'm having McDonald's for lunch. Oliver, question.
So you want us to write that out every single time, the MG3P2 is product 2P?
Well, this is very, very basic. All right, this is just an example, okay? Just an example. All right, so let's go over to the other side of our chart.
You get extra onions on your cheeseburger?
Do I get what?
There's extra diced onions on your cheeseburger at McDonald's.
No, I
So
don't.
good, you should try it.
The other side is called the 5 types.
Is this still on the?
This is on the right side, okay? Because that should have basically filled the left side, right? Man, I'm good. I planned that, all right? I'm going to give you a definition, I'm going to give you a general form, and then an example of each of the 5 types. Type number 1 is called synthesis. So the first of the 5 types of reactions is called synthesis. When you hear the word synthesis, what do you think of? Photosynthesis. Ever think of like synthesizing, right? When you're synthesizing, what are you doing?
Changing.
When I'm synthesizing something, what am I doing?
Making.
I'm putting something together, right? Yes? So a synthesis reaction is putting 2 things together, to make one. Putting 2 things together to make one. Here's the form. The general form is A plus B yields AB. Yeah, AB. A plus B yields AB. A plus B yields AB. What? Antonio Brown, yes. Here's an example. Example, sodium plus chlorine gas. Sodium plus chlorine gas. So your brain wants to say, well, the product is NaCl2. No, it's not. All right? Why is this Cl2? Cl2 is a what?
Non-metal.
True. True.
Well, I don't know exactly what
What is special about Cl2? And Br and I and F and O and N.
Super reactive.
Do you guys remember the diatomic corner?
No.
The elements that never exist by themselves in nature? We talked about that?
Oh, yeah.
So H2, NO, Cl, Bri, that's a diatomic. So you'll never just see plain Cl, right? So I have to write the product. This 2 has nothing to do with my products. The products have all to do with the charges. What's the charge on sodium?
1.
+1. What's the charge on chlorine?
Minus 1.
-1. Is that a perfect match? So my product is NaCl, right? This 2 is only here because that's a diatomic element, all right? The only way to get a 2 here would be this first thing has to have what charge? It would have to have a +2, right? And not if you're kind of okay with that. Okay.
But then it's not balanced.
It's not balanced, you're right. So to balance it, because I have 2 here, what coefficient has to go in front of this whole compound? 2. So that distributes, right? So I now have 2Na and 2Cl. So what coefficient has to go in front of Na? 2. That is balanced. Well done. That's balanced. That's a synthesis reaction. Type number 2 is called decomposition. Decomposition is the exact opposite of synthesis. So decomposition is, what do you think of when you think of decomposition? Breaking down. Decomposition is breaking apart. All right? Breaking apart. So we're ripping something apart. So the form is going to be AB. AB yields what? A plus B. You got it. A plus B. Let's do an example. Let's do water. H2O. So H2O, what is that going to break into?
H plus
2A plus.
It's going to break down into H2 plus O2. Why?
There's no O to be
They're both diatomic elements. You will never have plain H. All right? They're both diatomic elements, H2 plus O2. Are you guys okay with the diatomic elements? Because on this side, what's hydrogen's charge? It's a plus 1. What's oxygen's charge? That's why that's H2O. Over here, these are just by themselves. So when they're by themselves, you don't care about the charge, but they're diatomics. So if this was just a metal by itself, it would just be like Mg, right? But because they're diatomics, you have to do the 2. Are you guys okay with that? Is it balanced?
Yeah.
No,
No.
it's not. Because I have 2 oxygen here.
Yeah.
Only 1 oxygen here, so what coefficient has to go in front of this? 2. But that also changes my hydrogen on the left to how many? 4. So I have to put a coefficient of what in front of this hydrogen? Boom, balanced. That is balanced. Second type. All right? What's a diatomic element? Elements that don't exist by themselves in nature.
Because you remember when we had the thing where we...
Right, when we were doing the covalent compounds showing the circling, right? So we started out with F2, right?
Yeah.
Because fluorine has a share. Then we went to O2, which has a double bond. Then we went to N2, which has a triple bond, right? And then also Cl, Br, I, and H. So you just have to know those. You just have to know those. They don't exist by themselves in nature. Which takes us to our third type. Our third type of reaction is called single displacement. Single displacement. And this is going to take us back to the year 2006. Are you born yet?
No.
Okay. So the year's 2006. I am 3 years into college. I'm back already, and it's my brother's senior prom. This is a true story. All right? It's my brother's senior prom. So my brother, his name is Andrew. All right? Oliver can attest for that. He had this crush on this girl named, we'll call her Betsy. All right?
Is this your story?
What?
How would he know what you were?
He goes to our church.
Is this your story?
Oh.
What?
Is this your story?
This is a story about my brother. All right? This is a true story. Huh? He can smell. All right? So Andrew wanted to go to prom with this girl named Betsy. Okay? The thing about Betsy is she's one of the out-of-town girls. Okay? If you've ever brought a date to a dance from out of the school, you got to fill out a bunch of paperwork at the office, right? Anyone ever have to do that? No? Okay. Maybe you will sometime. Okay? So he's not like, I don't know how to describe my brother. He's outgoing, but like not as outgoing as me. But like he got the guts up to ask Betsy to prom. So he asked Betsy to prom. Betsy says yes. All right? And he fills out all the paperwork. Prom comes. I was there for prom pictures. I don't know why I was there, but I had nothing else to do, I guess, that night. So I went to pictures, watched them all get their pictures. And, well, Ainsley does my brother too. Anyways, so gets to the dance. When we had prom wasn't in the gym, it was in the commons, because this is at Worcester High School. My brother and I both went to Worcester High School. And the dance is going great. Andrew and Betsy are having a great time. Till about 80, 90 minutes into the dance. What usually happens about 80 to 90 minutes into every dance?
Pants
The first slow song. Pants did not rip. Pants did not rip, all right? It's the first slow dance. So the music comes on, and Andrew can't find Betsy. So Andrew is scanning the commons, and there's Betsy with one of the football studs, Chad. What had happened was Betsy liked Chad, used my brother to get to Worcester's prom so she could dance with Chad. And my brother is left by himself for the rest of the night. He got yachts. So,
You make fun of him for it?
no, he doesn't even know I used this story. But it's a true story, all right? So what happened to my brother is this third type, he was singly displaced, okay? He was singly displaced because this is where one thing, all right, one thing kicks another out. Where one thing kicks another out.
Betsy's a thing.
What?
Betsy's a thing.
Well, I was using people as an example because here's the form. The form is Andrew and Betsy plus Chad Oh, man, I'm good. All right. Andrew and Betsy plus Chad. What is that going to give us? What's by himself on the other side? Andrew's by himself, right? Right? So here's Andrew, singly displaced, plus what? Now be careful. This matters how you write it. Because Andrew's positive, Betsy's negative, Chad's positive. So it'd have to be CB, right? Because what always comes first in a compound? The cation. Hopefully you got that right on the test. All right? Andrew plus CB. All right? That is single displacement. That's a pretty good story, right? Oh, but there's better coming up. There's better coming up. So, no, this is with me. Here's the example. MgOH2. MgOH2 plus P. Plus P. Which two things are going to switch spots?
OH and G.
OH and P. Why? Because those both have what type of charge? They're both negative, agreed? Yes? So I know that OH and P are going to switch spots. So what is going to be by itself on the other side?
OH.
What's going to be by itself on the other side? No, Mg is going to match up with P.
Oh.
Right? OH is by itself. So here's OH. Plus, what's the charge on magnesium?
Positive 2.
Plus 2. What's the charge on phosphorus? 3 minus. Is that a perfect match?
No.
So what is it?
Mg3 plus 2.
We already did this one. Mg3P2. All right? Mg3P2. Is that balanced? No, but let's not worry about that right now. All right? Because I want to get to the next story. All right? I want to get to the next story. Story number 4. Type number 4. We're going to take it back farther into history. The year is 2002.
Still not born.
You're way not born now. All right? 2002. Maybe your parents weren't even married yet. Who knows? All right? Maybe your parents didn't even know each other yet. 2002. You guys ready? I'm in band. All right? I'm big into band. I still play my trombone now. All right? So why?
You just said you've been.
Maybe I will. Okay, maybe before.
Last day of school.
Maybe before the end of the year.
If we all ace the midterm.
Okay.
That's not gonna happen. So,
That is not happening.
all right, we gotta keep going to finish this. Okay? So, I played trombone. I'm a junior in high school, and I had a crush on a senior named Molly. Okay? Molly also plays trombone. It's ironic that I liked older women back then because my wife is 4.5 years than me now. Anyways, so have a crush on Molly. The problem is it's January and Molly is dating Ed, guy on the football team. All right, good guy. All right, good guy, one of my friends, but they're dating, so it's like I got no shot with Molly. Okay, we're friends. I think she kind of had an idea that I had a crush on her. You know, I like put the hints out there, right? But January comes around, Molly's dating Ed. February comes around, Molly's dating Ed. March comes around, Molly's dating Ed. April comes around, Molly and Ed break up.
Now's your chance.
All right? Now is my chance. But I don't pull the desperate high school guy move. I waited like the 2-week grace period, right? So she can like mourn her relationship with Ed, right? I wait 2 weeks, and I'm like, this is it. All right? Who here has ever been in band? No one here is in band? What about band in high school, though? So you guys don't know what the instrument closet is. Okay, this sounds weird, okay? Ainsley does. It's not like a closet. It's a huge room, all right, with a bunch of like little holes to put your instrument in, okay? So I put my trombone away. And I don't know how I know this, but I remember Molly was in the saxophone area, all right? And she was by herself. I'm like, this is my chance, all right? And back when I was in high school, you didn't have a promposal, okay? You just asked somebody to prom, okay? So I walk up to Molly. I'm like, Molly, will you go to prom with me? And her answer is, well, girls, you're the worst, okay? You are the worst. I'm confused because obviously she's saying no. I'm like, so no? She's like, no. She's like, I'm like, well, who are you going with? She's like, I'm going with Ed. And I'm like, okay, explain this to me, because here I am, I'm a dumb guy, all right? She's like, well, I broke up with Ed so close to prom, I thought I should still go with him because he couldn't find a date this close. And I'm like, no, no, no. Why do you have to be a nice person? She's like, but you should ask my friend Caitlin, and we'll go to prom together as a group. I'm like, okay, well, that's consolation prize. And Caitlin's super nice too. So I asked Caitlin to prom, she says yes, okay? So there's a group of 8 of us. It was me, Caitlin, Molly, Ed, Ryan, his date I don't remember, and this other couple who's like, I don't remember at all. So be more memorable than that couple, okay? They were seniors too. I didn't know them that well. Anyways, we go to dinner. What?
And you're still freshman.
No, I'm a junior,
Oh, okay.
because freshmen can't go to prom.
Oh, yeah.
I'm a junior, and like most of the people are seniors that I'm going with. Go to dinner. Dinner's great. Grand March is great. Get to the dance. All right? Grand March is like where you wear your tux, come out with your date on stage, they announce you, your parents take pictures, all that stuff. The dance is going great, having a fun time, until about 80 minutes in. This is a true story. I can't make this up, guys. Guess what happens 80 minutes into the dance? The first slow dance. I can't find Caitlin. All right? I cannot find Caitlin. So I'm scanning the comments, and I see Molly. And Molly's like, and I'm like, what? So I keep scanning, and I look over there, and Ed and Caitlin are dancing together. So hold on. So I go back over to Molly, and Molly's like,
Oh my.
so I'm like taking my chin off the ground. So I go over to Molly, and Molly's like, do you want to dance? I'm like, yeah. So we're like dancing, and I'm like, can someone explain to me what's going on? Because I'm a dumb guy, okay? So we're dancing, and she's like, so, you knew this. I'm like, I didn't know this. I'm like trying to figure out. She's like, well, since you asked Caitlin to prom, Caitlin and Ed started having a crush on each other. So they figured that they could just switch dates for prom, and then you and I could be together. I'm like, yes, that's exactly great. So I had no idea. And she's like, so do you just want to switch dates for the rest of the night? I'm like, yes, I do. And it was incredible, all right? It was incredible. It was a night of magic, all right, from that point on, because I got to dance with Molly. And we never dated after that, but it was a fun prom. So, but it ended up great. So what happened to us is we had some double displacement, all right? We had some double displacement. Double displacement is 2 things switching places. All right, 2 things switching places. So now nothing is left by itself. All right, 2 things are switching places. 2 things switching places. That's a true story, guys. All right, do you believe me?
Kinda.
You know what? I've got my prom picture in my desk.
Oh.
Here it is. All right,
Put it under the document camera.
true story. Here it is. To prove to you that this is real.
So who's who?
So, obviously, that's me. That's Caitlin. That's Ed. That's Molly. And Caitlin's pretty, but it's like I had more of a crush on Molly.
Yeah, Molly's
All right, what'd you say?
Molly's the one, not Caitlin.
It just depends on your type, okay? So that's Ryan, his date, and then them. I don't know who they are, okay? Eventually, this is going to be like one of your parents. It's going to be real awkward when that happens. Like, I'm getting close. Because, like, Max's mom was only a couple years older than me. So, like, we're getting close to, like, where this could be, like, some of your parents. Anyways, so there they are. There's Molly. There's Caitlin. Caitlin and Ed were dancing together. Me and Molly got to dance together. It was great. So, true story.
Dude, the random couple, she looks like evil, isn't she?
No, she was nice. She was nice, just not very memorable. So be more memorable than that. True story, guys. I have that specifically for that story. Yes.
Seriously?
Yeah. I found it a couple years ago. I'm like, I'm going to bring that in. So I did. What? I got the what?
So like nowadays it's like girls,
Oh my god.
Nowadays what?
if you get girls who have Riz, like W Riz.
Oh, I did not know that was a thing.
So like if you have Riz, that means like you get to go to prom with Molly. That means you got good Riz. Or-
Got it.
But you don't say good Riz, you say W Riz.
Oh. Well, I have a wife, so I don't have to worry about that.
Yeah, but,
If I had to worry about that, it would not be
yeah, but your
good.
wife's like, friends would say like that your wife has W-riz.
Oh.
Ah, got it.
Why is
Got
your
it.
marker like
I don't know why my marker's like this now, but we're going to deal with it. This is AB plus CD, all right? AB plus CD. What's that going to give me?
AC plus BD?
Positive, negative, positive, negative.
Oh,
AD
AD plus CB. AD plus CB. So the order within the compounds matters, but the order of the compounds don't matter. So you could have like CB plus AD, but it does matter within the compound.
Oh, so it doesn't matter if you flip them.
No, doesn't matter if you flip them. Example, NaCl, NaCl plus BeO. What's going to switch spots? NaCl plus BeO. What's going to switch spots?
No. Oh, it's
O and Cl or Na and Be, right? Doesn't matter. I'm going to do Na and Be. So on the other side, sodium is going to be matched up with oxygen. What is sodium's charge? Plus 1. What's oxygen's charge? 2 minus. Is that a perfect match? So what's it going to be?
Na2O.
Nice. Na2O plus beryllium is what charge? Oxygen is what I'm sorry, chlorine is what charge? Is that a perfect match? So what's my other one?
Cl2.
Nice. BeCl2. BeCl2. Is that balanced? No. If you wanted to balance it, it'd be like a 2 here. It'd be, I don't know. No, that's not right. Don't worry about balancing it, okay? Not important. We'll work on balancing next week. Because I want to get to the fifth and final type.
Is there a story to this one?
No, because if I related a prom story to this, it would be weird because it's combustion. All right? Hopefully nothing is burning at prom. All right? Combustion is literally just burning. All right?
Can we have a story about this?
Burning desire. No, I don't know. All right? I don't know. So here's the form. Any carbon hydrogen compound. So CXHY. That could be any carbon hydrogen compound. CXHY. In order to burn something, you must have oxygen plus O2. And the products are always the same. Okay? The products are always the same on combustion, so it's super easy to identify. It's always CO2 plus H2O. In fact, those last three things are always the same every single time. Those are always the same every single time. So if I was going to give an example, instead of X and Y, I'm just going to have numbers there, right? So I'd have like CH4 plus O2 yields CO2 plus H2O. That's a combustion reaction.
So it's only CO2.
It's always CO2 plus H2O for the products. Always. What I want you to do the last 4 minutes on the paper you picked up on the way in is see if you can circle the types of reactions that they're wanting you to do. See if you can identify these. And this will take about 4 minutes, so it's perfect. Follow the directions on that paper and see if you can circle the ones that are the ones that they're asking you to find. So it's going to be like circle